Hello everyone, and thank you for being here today. My name is Dmitry Novikov, and I am excited to present my final project. The core goal of my project was to develop a tool that can recognize common computer error screens and guide users to appropriate troubleshooting steps. I started by training an image classification model to identify different error screens, and then paired the output with a visually appealing troubleshooting poster that links users to the right solutions. The beauty of this project is that it makes dealing with computer errors less intimidating, especially for people who don't have a technical background. Imagine this. Your screen suddenly goes blue or black with a blinking cursor, and you don't know what it means. You panic, unsure what to do next. With my tool, all the user needs to do is take a quick photo or screenshot of the error screen. The AI model I trained will instantly recognize what kind of error it is and give it a clear name. From there, the user can match that name to the poster, click the link, and get the exact troubleshooting steps they need. For this project, I used Google's Teachable Machine and a free and beginner-friendly tool designed for quick image classification tasks. It's perfect for rapid prototyping and worked well for recognizing different screen errors. I created 4 categories for the AI to classify: the blue screen of death, the black screen with a blinking cursor, no bootable device found, and the common application had stopped working crash. As you can see on the right, this is a screenshot of the model being trained using my collected data. Each class has its own set of labeled images, and the interface made it very easy to test and retrain the model during development. Training the model started with gathering the right dataset. I manually collected about 20 images for each class, so that's 4 folders, one for each error type, each containing around 20 screenshots. Unfortunately, I couldn't find any pre-existing dataset for this purpose, which made data collection time-consuming and limited the size of my dataset. On the right side of the screen, you can see my desktop with the organized image folders that I used to train each class in Teachable Machine. Now, I would like to show you how the trained model works in practice. On the right side of this slide, you can see an image of me testing the Teachable Machine model using a screenshot of the blue screen of death, also known as BSOD. In this test, the model accurately classified the image as fixed blue screen of death with 98% confidence. Now, I'm going to demonstrate the model live. I will use my built-in webcam to scan 4 different types of error screens, one at a time, and we will see how the model classified them in real time. First, let's start with the blue screen of death. As expected, the model correctly identifies it as fixed blue screen of death within seconds. Second, the black screen with cursor. The model instantly identifies it as fixed black screen with cursor. Next, no bootable device found. Again, correctly labeled by the model. And finally, application has stopped working, and the model nails that one too. This live demo shows how easy it is for users to get quick feedback on what kind of issue they are experiencing. Instead of panicking or guessing, they can just scan the screen and get a clear, accurate name for the error. While the classification worked well, there was one big problem. Teachable Machine cannot output clickable links or interact with users beyond labels. That meant I had to find another way to bridge the gap between recognition and real help. To solve this, I designed a visual troubleshooting poster using Canva AI. The poster visually maps each error screen to its solution, and I manually added clickable links to the PDF so users could jump straight to help resources. This gave the classification output a functional next step. To create the poster, I used Canva AI. It helped me generate a clean layout, a fitting title, and icons that matched each error category. However, there were some limitations. Canva AI struggled with generating full instructional text and could not add hyperlinks directly into the design. So I stepped in to complete the design manually. The clickable links you see in the PDF version were added afterwards using Adobe Acrobat. Now I will open the poster so you can see how it works. So here is the poster I created using Canva AI. Clicking Fix blue screen of death opens a page with easy steps like memory checks and system restore. Next, black screen with cursor. It leads to safe mode, driver update, and repair instructions. Next is no bootable device found. It takes us to BIOS and bootable USB fixes. And application has stopped working. Links to crash recovery tips like reinstalling or running system checks. The idea behind this poster is simple. Once the model tells you which error you are facing, this poster gives you a direct path to the solution, with no need to search or guess. It is fast, intuitive, and user-friendly. Now let's take a look at the successes and challenges I encountered during this project. Starting with the successes, first, the AI model I trained was able to accurately recognize different types of error screens, which was the core goal. Second, I came up with a creative and practical solution by designing a poster that visually connects the AI's output to real help. Third, this turned out to be especially useful for non-technical users. It takes the guesswork out of tech issues. And finally, even with limited data, the AI still performed well thanks to the clean training and focused classes. Now the challenges. One major obstacle was the complete lack of pre-existing datasets for these specific error screens. I had to gather all the data myself. I also worked with a fairly small sample size, just about 20 images per class, which limited the training depth. Next, while Canva AI helped with the poster design, it could not generate clickable links, so I had to manually edit and finish the poster. And finally, Canva sometimes misinterpreted my prompts, so I have to go back and refine the generated content by hand. Conclusion. This project combines two AI tools, Teachable Machine for classification and Canva AI for poster design. By integrating them, I created a hybrid support tool that both identifies error screens and links users to real troubleshooting resources. The result is a practical AI prototype that provides real-world value. Teachable Machine handles the recognition, and the PDF poster gives the user immediate help through clickable links. Although I faced challenges with dataset limitation AI design constraints, the overall process showed how AI can be combined creatively to solve real user problems. Here is my reference list, and thank you for the attention.